The B-2 Spirit bomber is a marvel of modern aviation technology. It's often called a stealth bomber, and that's because its unique flying wing design and advanced materials make it nearly invisible to enemy radar. It really represents the very peak of American air power, serving as a symbol of strategic deterrence and global reach. One of these incredible machines was named the Spirit of Kansas. It was actually the first operational B-2 bomber to enter the United States Air Force fleet. For years, it served as a cornerstone of America's long-range strike capability, a silent guardian in the skies, ready to perform missions anywhere on the globe with unparalleled stealth and precision. It's truly a testament to engineering. On the morning of February 23, 2008, the Spirit of Kansas was scheduled for a routine mission. The aircraft was stationed at Andersen Air Force Base in Guam, which is a strategic outpost in the Pacific Ocean. Its task was to return to its home base at Whiteman Air Force Base in Missouri after a 4-month deployment. This type of rotation was pretty standard for the B-2 fleet, allowing the Air Force to maintain a continuous bomber presence in the region. The crew, 2 highly experienced pilots, prepared for the long trans-Pacific flight. The weather was clear, and all pre-flight checks indicated that the complex aircraft was ready for departure from the tropical island airbase. The Spirit of Kansas, designated with the tail number 89-0127, held a unique place in aviation history. As one of only 21 B-2 bombers ever built, it was an exceptionally rare and valuable asset. Its role in the Air Force was critical, projecting power without ever being seen. The aircraft had a distinguished service record, participating in numerous operations and training exercises that really solidified its reputation as a reliable and formidable weapon system. Its presence in Guam was part of a larger strategy to reassure allies and deter potential adversaries in a vital part of the world. The flight home was supposed to be just another entry in its long and storied logbook. The cost of a single B-2 Spirit bomber is staggering. With development costs included, each aircraft is valued at approximately $2.1 billion. This makes it the most expensive aircraft ever built by a significant margin. Losing one was not just a financial blow, but a significant hit to a very small and specialized fleet. The Spirit of Kansas was more than just metal and electronics. It was a national treasure, a piece of cutting-edge technology that few nations could ever hope to replicate. Its loss would be felt deeply across the entire Department of Defense, prompting an immediate and thorough investigation into what could have possibly gone wrong on that fateful day. The takeoff sequence began like any other. The Spirit of Kansas taxied onto the runway, its powerful engines roaring to life. The 2 pilots inside the cockpit initiated the takeoff roll, accelerating the massive flying wing down the strip of asphalt. Everything appeared normal as the aircraft gained speed, its nose lifting gracefully from the ground. For a few brief seconds, the bomber was airborne, beginning its climb into the clear blue sky over Guam. It was in this critical phase of flight, just moments after leaving the ground, that the situation turned into a catastrophic emergency, unfolding in full view of the control tower and ground personnel. Suddenly, and without any obvious warning, the aircraft's left wing dipped sharply. The pilots fought to regain control, but the bomber refused to respond to their commands. The sophisticated flight control system seemed to be feeding the aircraft disastrously incorrect information, causing it to behave erratically. The plane yawed aggressively to the left, its wingtips scraping along the ground next to the runway. The pilots were now passengers in a machine that was no longer listening to them. The bomber, losing all forward momentum and altitude, began to stall and plummet back toward the Earth, its flight lasting only a few terrifying seconds. Fortunately, the pilots were equipped with advanced ejection seats designed for just such an emergency. As the B-2 began its uncontrollable descent, both crew members made the split-second decision to eject. They were blasted clear of the doomed aircraft just moments before it crashed. The bomber slammed into the ground just off the side of the runway, erupting in a massive fireball of jet fuel and debris. A thick plume of black smoke billowed into the sky, marking the grave of the multi-billion-dollar aircraft. The dramatic crash was captured on video, providing investigators with a clear view of the bomber's final, tragic moments of flight. The 2 pilots parachuted down safely, landing near the crash site with only minor injuries. Their survival was a testament to the effectiveness of their training and the reliability of their ejection systems. They were the only 2 people aboard the aircraft. While the crew was safe, the Spirit of Kansas was a total loss. Fire crews at Andersen Air Force Base rushed to the scene to extinguish the intense blaze, but the aircraft was completely destroyed. The wreckage smoldered on the airfield for hours, a stark and expensive reminder of the inherent dangers of military aviation, even during what was supposed to be a routine departure. In the aftermath of the crash, the Air Force immediately launched a comprehensive investigation. The primary question was simple: what could bring down one of the world's most advanced and reliable aircraft? Investigators meticulously combed through the charred wreckage, searching for clues. They analyzed the flight data recorder and cockpit voice recorder, which had been recovered from the debris. They also reviewed maintenance records and interviewed the 2 pilots who had miraculously survived the incident. The entire B-2 fleet, now down to just 20 aircraft, was temporarily grounded as a precaution until the root cause of the accident could be definitively identified and addressed by officials. The investigation soon zeroed in on the aircraft's complex air data system. This system uses a series of sensors, known as pitot tubes, to measure critical information like airspeed, altitude, and air pressure. This data is then fed into the flight control computers, which make thousands of micro-adjustments per second to keep the inherently unstable flying wing design stable in the air. The official accident report, released several months later, concluded that the crash was not caused by pilot error or mechanical failure in the traditional sense. Instead, the problem stemmed from moisture that had gotten inside 3 of the aircraft's 24 air data sensors. This moisture, a result of Guam's humid climate, skewed the data being sent to the flight control computers. During takeoff calibration, the wet sensors provided incorrect air pressure readings. The computers, believing this false information, calculated an inaccurate airspeed and a dangerously incorrect angle of attack. This caused the flight control system to command a premature and overly steep rotation, or liftoff, at a speed that was too slow to maintain flight. The aircraft essentially thought it was flying faster than it actually was, leading it to pitch up too aggressively and enter an unrecoverable stall just seconds after its wheels left the ground. The pilots had no way of knowing their instruments were lying to them. They followed their procedures perfectly, but they were fighting a losing battle against a computer system that was being fed bad data. The aircraft's flight control system, designed to make flying easier and safer, became the very instrument of its destruction. The crash was a sobering lesson in the vulnerabilities of even the most sophisticated fly-by-wire systems. It highlighted how a small, seemingly insignificant issue like moisture in a sensor could have catastrophic consequences for a multi-billion-dollar piece of military hardware, revealing a hidden weakness in its design. The loss of the Spirit of Kansas had an immediate and profound impact on the United States Air Force. The grounding of the entire B-2 fleet was a significant move, temporarily sidelining a key component of America's strategic bomber force. The investigation's findings prompted a swift and thorough review of all B-2 maintenance procedures. New protocols were immediately developed and implemented to prevent moisture from accumulating in the air data sensors. This included heating the sensors before takeoff to dry out any condensation, a simple fix that would prevent a similar accident from ever happening again in the future. The crash served as a critical learning experience for the entire aviation community, not just the Air Force. It underscored the importance of understanding the environmental effects on highly sensitive electronic systems. The reliance on automated, computer-controlled flight systems is a hallmark of modern aircraft, from military bombers to commercial airliners. The Spirit of Kansas incident demonstrated that these systems are only as reliable as the data they receive. It pushed engineers and designers to build in greater redundancies and to develop better methods for detecting and isolating faulty sensor data before it can lead to a catastrophic failure of the entire system. This accident, while tragic and costly, ultimately made the B-2 fleet safer and more robust. By identifying a critical vulnerability, the Air Force was able to implement a solution that strengthened the entire program. The remaining 19 B-2 bombers continue to serve as a vital part of the nation's defense, benefiting from the hard-learned lessons of that day in Guam. The incident reinforced a core principle of aviation safety. Every accident, no matter how devastating, provides an opportunity to learn and improve. The goal is to ensure that the same mistake is never repeated, protecting the lives of future pilots and preserving valuable assets. The legacy of the Spirit of Kansas is therefore twofold. It is remembered as the first and only loss of a B-2 Spirit bomber, a sobering reminder of the risks inherent in flight. But it is also remembered as a catalyst for positive change. The investigation and the subsequent safety improvements have had a lasting impact on aircraft design, maintenance, and operational procedures across military and civilian aviation. In this way, the loss of the Spirit of Kansas was not entirely in vain. The lessons learned from its final flight continue to contribute to the safety of skies all around the world, ensuring that future aviators are better protected from such hidden dangers.